Again, parts. I love letting u be natural log, so we're going to let u be the natural log thing here, natural log t squared. dv will be everything else, t dt. du is derivative of this. Chain rule says derivative of something squared is 2 something derivative of the inside. v is the integral of that is half t squared. You should have a dt on u. So we want uv minus integral v du. That's going to be uv is half t squared natural log t squared minus the integral of v, half t squared, du, 2 natural log t, 1 over t dt. Some stuff cancels. A half cancels with a 2. 1 over t cancels with one of those t's. I'm left with the integral of t natural log t. This wants parts again. Let u be natural log t. du is 1 over t dt. dv is everything else. It's t dt. So v is the integral of that is half t squared. Could put plus c, don't need it. Actually, I hate this. I don't like putting a minus here because it's going to be minus the whole uv minus integral v du, and I'll have to distribute the minus in, which is gross to me. I forgot to deal with that beforehand. I guess what I want to do is rewrite this as plus the integral of negative t natural log t. So now dv was negative t, and v is negative 1 half t squared. And now I don't have to deal with this minus outside the integral. All the minuses are built into the parts of the u and the v. So I get stuff plus uv minus integral v du. uv is negative a half t squared natural log t minus the integral of v, negative 1 half t squared, du, 1 over t dt. These negatives cancel. This is t squared times 1 over t is t. So this is the integral of 1 half t. The integral of half t is 1/4 t squared. Plus this part's still there, negative 1 half t squared natural log t. Plus this part's still there that I haven't been writing down. 1 half t squared natural log t squared. This is one of the ones where taking the derivative of this and seeing why you get that, you can learn something from doing that. Find the average value of this mess over this interval. So I want to take 1 over the length of the interval times the integral over that interval. This isn't really anything to do with the exam 3 material. We talked about average value on the last exam, but we didn't know how to do this by hand on the last exam, so there's a couple of these. Just do the problem now that you know how to do integrals better. How do I do this integral? I do it by splitting it up. That's x over x plus 1 over x. The integral of x over x is the integral of 1. The integral of that is x. The integral of 1 over x is natural log absolute value of x. Now plug in 3 to 5. I forgot I use a bar instead of a bracket. So I get 1 half. Plug in 5 minus plug in 3. Plug in 5, you get 5 plus ln 5. Plug in 3, you get 3 plus ln 3. 5 minus 3 is 2. Plus ln 5 minus ln 3, all times a half. I get 1 plus half ln 5 minus half ln 3. Cool. We can type this into a calculator and get digits, but that's the less impressive version of the answer because we could have gotten digits without learning the fundamental theorem of calculus and doing an antiderivative and all that. Like your calculator can get digits, so I mean, it's not wrong to put the digits, but this is the one I'm looking for to see if you got it on the page somewhere when I'm grading. Cool. If you have more questions before the exam, I'm available.